Hello and welcome to another episode of Math with Sohn. Today we're going to be doing a very important topic for AP Physics 1 and AP Physics 2, and that is called linearization. Okay? So linearization is a method of determining a constant. That constant could be the mass of something, gravity, it could be the radius, it could literally be anything that is constant. And it is a method of doing something to where that would be more accurate. Okay? So typically, you will have to be the one to determine what the y-axis and the x-axis would be. In these first cases, we're starting baby steps, and I have given that. All right. So if you look at your acceleration, centripetal acceleration, according to this, and your velocity, if those two were plotted, then this graph would be very unique because this is a velocity squared. Okay. So if you wanted to linearize it, because this is written in the way that it is, this would be the way that it is currently written is a parabolic. So I'm doing two things here. This is the way it is currently written, okay? I want to take it from a quadratic and turn it into a line. In order to take it from a quadratic and turn it into a line, I'm going to rewrite this slightly. I'm going to peel off that 1 over r, and then I'm going to write a v squared, okay? And if I do that, now, let's cross off this proportionality thing. Now, I can look at this, and I can make this my slope because it's y is equal to mx. So if 1 over r is my slope, then I would need the x to be not just a v, but a v squared. And if I did that, if I did v squared, then I would have a line. And that line, the slope of that line would equal 1 over r. And I could solve for the slope, and then I could set that slope equal to 1 over r to figure out what the radius is going to be of the circle. Okay? So, let's try another one. Here, we have k being plotted, which I don't even know what k is. Maybe the spring constant. 1 half mv squared is equal to 1 half kx squared, something like that. All right, so we're solving for k. We got a k here, but let's say that I wanted m to be represented in some way as the slope, okay? So let's think about that. Currently, we have v for y, that's fine, is equal to the square root of 2 divided by the square root of m times the square root of k. If I wanted to make this a straight line, I don't want k to be here because k is underneath the square root symbol. So if I want this to be a straight line, I need to represent this as a square root of k, okay? If I represent it as a square root of k, now this is going to be my x value, which means all of this stuff, all of it, can represent my slope. Now, it is important to note that you do not have to make this just k and have a whole bunch of things represented as your slope. You would also be allowed to have this as like the square root of 2k, and then your slope would only be 1 over the square root of m. But for right now, let's just say that this is a line, and if you found the slope of that line, let's say that the slope happens to equal something like 4. You can calculate the slope. Here, we're not going over how to calculate the slope, y2 minus y1 over x2 minus x1. If the slope is 4, then you would say 4 is equal to the square root of 2 over the square root of m, if the slope was 4. And then you could solve for m. You would multiply by the square root of m. You get 4 square root of m is equal to the square root of 2 over 1. Divide by 4, so we'll put a 4 here, and the 4 would cancel. And then you would square both sides. And that's how you would get m. You would get m is equal to the square root of 2 over, I messed up, m, it's off the screen anyways, m would equal the square root of 2 over 4 quantity squared, and then you could solve that. It would end up equaling, I think, 1/4. But that's not the point. You can solve. I understand that we're mathematically good at this point. So you would end up getting your slope, figuring out what all the slope is equal to, and then squaring or doing whatever mathematical operation may be. In other cases, you might have multiple constants that you have to plug in. We're going to see that maybe on some of the actual AP examples on a different video. Okay, so let's move into some that are a little bit more complicated. Let's say here we have t, that's the y value, clearly. We got v, which I'm going to need to replace because this is squared. It would need to be a v squared to make a line. All right. Now let's say that you wanted to figure out g. If you wanted to figure out g, notice that that's not a part of the slope. That's not a part of the slope. You would still need to square the v to make it a line. But your slope, in this case, your slope would equal m over r because these would represent the slope and this would represent the x. The v squared is the x, which means your slope is m over r. If you wanted to find g, that is a part of the y-intercept. So you would graph your line, you would plug in some stuff, perhaps you know what the mass is, okay? You would need to know something. You can only have one constant that is not known in most of these cases. Most, not all, okay? We're going to do this one a few different times. I think I have it down here again that we can do a little bit differently. So here, let's say we graph it. Let's say we know what the mass is, and we graph it and we get a line, which I'm going to represent something like this. It could also be a negative slope, okay? That slope, whatever that slope is equal to m over r. This y-intercept is, whatever this y-intercept is equal to m and g. Okay, now let's say that the y-intercept is, we'll keep it consistent, we'll say 4. Okay, so 4 is equal to mg. Assume that you don't know what g is and you're trying to experimentally determine what gravity is, and you're hoping to get 9.81. Okay, now in order for this to work, let's say that our mass of our object was provided, and if our mass of the object was provided and it was 1/2 a kilogram, then you could plug that in. 4 is equal to 1/2 times g, and if you divide by 1/2, you would get an experimental value of gravity of 8 meters per second squared, which is not perfect, but it is maybe within the margin of error that AP would accept, okay? So that shows you how the y-intercept can also be used. In AP1, it's used less frequently. In AP2, it's used probably about 30% of the time. It's used quite a bit in AP2. AP1, it's just less often because there's less equations that AP has for AP1 students that deal with it, but it's still a possibility, okay? So we got another one that's similar, but this time I want to find the experimental value for m, okay? So if I want to find the experimental value for m, I didn't know m. I would actually, sorry, I take it back. They have m here. Let's see. What is some things we could do if we have that? Well, we have a few things. So here the issue is that there's 2 m's. If there's 2 m's, that's a problem because you can't have an x value that's changing. If your mass is changing, then we have an issue here. But what we could do is we could factor out the m, and you'd be left with like a v squared over r plus g. Okay? Now let's say that the velocity is constant, and the r is constant, and the g is constant. Let's say all of that is constant, that the velocity was constant, the radius was constant, and gravity was constant, which for a lot of cases could be. Then your m, in this case, is your x value, and all of that can be represented by the slope if it is held constant, which they are forcing this m to be the x value according to this graph. So therefore, it is possible, and if you graphed it, you would have no y-intercept. At least you shouldn't, because there's no like plus b at the end of this. And therefore, you would get a slope, and that entire slope would equal v squared over r plus g, and if it was equal to 4, like we've been keeping consistent as like the random things that you solve for would equal 4, then you could solve for anything here. Like let's say that the v was not constant or the r was not constant. Whatever one you didn't know, you could solve for that experimental value. Okay? That one's a really weird one. It is possible, but that's neither here nor there. Okay? We got one more. We got p and t. If t is plotted here, that means that the n, the k, and the v would all be a part of the slope. So the slope this time, whatever the slope would equal, which apparently is 4 according to the theme of the day, that means that 4 would equal nkb, Boltzmann's constant, over volume. Okay? And you could solve for the volume or the n or the kb, whatever one was held constant and what was not provided. If you have 2 things not provided, you need to go back to the drawing table because something else is funky. Okay? So that's going to do it for this portion of it. That was the basic overview. We're going to do an actual AP problem on the next video. I hope to see you then, because these are tricky and they are almost always tested on the AP exam, and they're easy points, because if you just know how to do linearization, you don't have to know any physics other than maybe what formula you might have to think about. Okay? See you then. Bye.